All right, ladies, I wanted to record a video showing you an example on how you calculate monthly payment based on the amount of principal, rate, number of payments per year, and number of years. Now, the first thing you'll notice is the equation looks similar to what we have done with the compound interest formula. Notice that we do have the number of times per year in several places, the N. So the first thing you can do if I'm talking about making a monthly payment is just to switch all of those N's to 12. So now I'm going to be talking about 12 times a year the whole time. That will never change. What will change depending on the problem is the principal. Now this could be, in the case I'm going to demonstrate for you today, the total amount that the car cost. In other words, the amount that I am financing, assuming that I don't have a down payment. This could be also any other kind of a purchase, so another loan that you're paying back, a monthly house payment, and so on. So as an example, we have a monthly payment for a 3-year loan of $15,000. So I'm buying a car at $15,000. $15,000 will be my principal. I'm going to repay it over the course of 3 years. So 3 is my lowercase t, and 7% is my rate of interest that I'm going to be charged. So scrolling up just a little bit, here is what that would look like as I plug in those values into the formula. So I have 15,000 times 0.07 over 12 divided by 1 minus the quantity 1 plus 0.07 over 12 to the negative 12 times 3 power. Now we have done some with negative exponents this chapter as well. Because this whole denominator is not all to the negative exponent, I'm actually going to leave that where it's at. In other words, I'm not going to move it. One of the few instances where I'm not going to say, look, I have a negative exponent, it needs to move to the numerator. I'm going to leave it as is. This is such a large equation that I would recommend doing it in 2 separate pieces, at least in your calculator. So for instance, I would type in the 15,000 divided by, times 0.07 divided by 12, and get the numerator, or the top half, 7.5, and then go ahead and do the rest of the denominator. 1 minus quantity 1 plus 0.07 divided by 12 to the power of, and now if your calculator has a new operating system like mine where it's going to go ahead and put the negative 12 times 3 all in the exponent, that's fine. If your calculator just gives you the up caret, then I would recommend either putting that to the negative 36 power or using parentheses to put negative 12 times 3 in the parentheses so that the calculator recognizes the whole thing as part of the exponent. Hit enter. It's going to give you a long, very small decimal, very similar to how we did our compounded interest equations a couple of classes ago. I'm going to recommend rounding out to at least 4 decimal places when you get a big ugly decimal like that, until the very end, in which case you can make that a little bit shorter. So then I can type in 87.5, which is what I got for my numerator, divided by 0.1889, enter, and at this point I am talking about a value in dollars, so I'm going to go ahead and round out to just 2 decimal places as a final answer. So $463.21 is how much I'd be paying monthly for 3 years if I wanted to buy a car that was worth $15,000. Now, is this reasonable? Well, if I had just not had any interest involved and taken $15,000 divided by the 36 months I was going to borrow the money, that alone would be $416.67. So the fact that I got my monthly payment that includes the interest at $463 does seem reasonable. Now, the second piece of this is, as I have calculated how much I'm going to be paying monthly, I'm interested also in how much I'm going to be paying total. So you know that when you have a loan with interest, you're not going to be paying just that $15,000 back. I'm going to be paying back $15,000 plus interest. So I'm going to take the total number of monthly payments, which in this case we found was monthly payment was $463.21. And I'm going to multiply that by the number of months. So in this case, if it's 3 years, I would multiply that by 36 because I'm going to be paying 36 monthly payments. So I'm going to get 463.21 times 36 and get a total. My $15,000 car will actually end up costing me $16,675.56. If I had had a 4-year loan, that would have been the monthly payment times 48. 5-year loan would be times 60, and so on. I hope this helps. If you have any other questions about monthly payments, you can ask me when I see you in class next.